So the course is PHY 3115. I'm expecting the petroleum students, but I'm not going to advertise as well. If they hear there is a course and they come, I'll take them up. If they don't come, I'm not interested in sourcing for students. Electronics. So we are going to use the electronics we did in your second year, last semester, and then see how we can integrate it with instruments. So this is electronics and instrumentation. We used an oscilloscope. This time we shall know how an oscilloscope works, how we can calibrate it, and all other instruments, how we can program the instruments to do the data acquisition we wish to have, and then how to use the sensors and transducers to do several things. So I brought you the one of the robot that uses one of the sensors so that you see, but you build this yourself. There are two. One is Explorer, this one is Line Follower. And then you build them during practicals, one of the practicals, so that you are able to go with something. How about you are very few? I can give you the guidelines for the lab. They are the same, although they should be different, but they are the same, just to make sure that where you need to do experiment and present your report, you use the same format. I'm going to change anything. So let's look at the course outline, and then it is during the course outline that I'll be able to briefly explain a few things and emphasize it. So the course description is that this course introduces the student to the physics of basic transducers and the electronic circuits. Do you know, have you ever heard of a transducer? What is a transducer? Eh? You just talked about it? Or someone talked about it? In acoustics. And what was it about? It's a converter. So you have your music, and then it can convert it to where? From music to electronic signal, from electronic signal to music. So the keywords in this course are sensors and transducers. So a microphone senses my sound and then takes it into the system. If it is a public address system, it takes it into the system, gets amplified, gets modulated, gets whatever you can do. And then the speakers have to, so I have two things here. I have a microphone and I have a speaker. So can you differentiate them as A or B? So would a microphone be a sensor or a transducer?
Sensor. It's a transducer.
Margaret, microphone is a what? Is it a sensor or a transducer? It's a sensor. So she's saying it is a sensor. A speaker would be a sensor or a transducer? No.
Sensor.
A microphone, sorry, a speaker, a loudspeaker senses. When you talk of a sensor, it goes with a stimulus. Something that you can stimulate, then it feels what you are, the signal you are making it. So Would the speaker be a transducer or a sensor? Transducer. Because you have just wires coming to the speaker, all of a sudden you see the diaphragm vibrating. So this is the simple way you can differentiate between the two. Nevertheless, you are going to be able to have the basic physics of transducers and how we use them in electronic circuits. The basic transducers covered are, you can have a radiation transducer, you can have a thermoelectric transducer. Radiation is if the light is able to be radiated on the transducer, then it is received inside and how can I say, interpreted in a way that now that interpretation will be changed into a signal. So if you have, for example, a thermostat, and then the heat is shown on the thermostat, that heat now makes the thermostat to either switch off or switch on the system. Like if you look at the cooling system of the car, when the water heats up so much, the thermostat makes sure that the water flows away, and that's how the heating system of the car works. It's the water from the engine that flows through the heating of the car, and then as the water passes, then some of the heat is blown into the cabin, and then you feel the warmth. Then when it is so, if you want the coldness, AC, then you make the air to come from the surroundings, and then be blown by the fan, and then that air flows towards the system, and then you feel it is so cold. So the thermostat will be able to do that. Thermoelectric, if you make light photons fall on an electrode, and then you release some electrons, and then they get multiplied, you have an electrode here, you have these photons falling on, and then you can have multiple. So here you have them multiplying in U2, and now here we have, here coming out of here, now there are 4. You make them come here, you have 8. So by the time you get the ones which are coming out here, they are more. It was a little light here, but the photons, the electrons coming out of here are able to be amplified and then give you a signal. So if you wanted to make sure that when it shines, for example, when we talk of an LVR, a light dependent resistor, the one which is used to switch off street lights. So when the light shines on it, the resistance is increased. When the resistance is increased, then you have the circuit being cut off, and then you switch off the lights. In the evening, when the light reduces, the resistance decreases, current starts flowing, and then the lights go on. If it becomes hazy, like it is about rain, the LDR sees that there is, the light becomes so small to a threshold, and then the current starts flowing, and then the lights go on. You have ever seen in town when it is threatening to rain, and then the lights go on? As if people don't know, they can't see, but it is not people doing anything, it's just an automated sensor which would have sensed the bit. The other part of the description, of course, the mechanical one, the Explorer robot has a bumper with a touch sensor, so when you touch it, it will be able to feel the signal and then do whatever it is supposed to do when the signal goes in it. And then we eventually, the capacitive, that phone of yours, when you are doing this scrolling, you are using capacitive, capacitive sensing. And then we have inductive transducers. And then finally we have the elements of the communication system, then examples of measuring instruments and regulators will also be presented. So we shall look at how instruments work, and then after looking at how instruments work, also look at how regulators is not regulating roads or whatever, but like Like what did we use, or what did we talk about as a voltage regulator in electronics? Experiment 2. The Zener diode was branded as a voltage regulator, so we shall be able to look at that. And, but this course should be able to make you look at a practical sense. How is electronics applied? That's the essence of this. So the word instrumentation is how we can get instruments, electronic instruments, and be able to make them work to our benefit. And these instruments, we look at how we can interpret, how they should be able to interpret the stimulus, and then the response becomes the measurement we get. Basic milliammeter, for example, milliammeter, you put in the current, and when you put in the current, and it goes through the coil, this coil which is wound on the aluminum, on the iron core, on the aluminum frame, around the iron core, with the metal jewelings, and these metal jewelings here, with the hairspring here. So you got a current coming in as a stimulus. So you got a current coming in, comes here, causes the torque. So you have the Fleming's left hand rule. If the current is going up here, and then the field is, if these were our concave pole pieces, concave pole piece, and then you have the field going from current up. Let's take the field to be going from north to south. Then you will have the force here going this way, and the force on the other side hidden there will be coming this way. And when you have two people in a relationship, they form a couple. When you support Arsenal, she will support Man U. If she finds out that you like her dad, she will pretend she likes the man. So that's how we say we have a couple. A couple, two forces equal but opposite. Then you get this one, the torque. So the twist makes this pointer here to read the scale and then start counting. The magnitude of the current you are bringing in will be related to the magnitude of the response of the pointer to give you the value of the. So this is it's a detector, it's a sensor, it's a mirror, it's a sensor. The current is your stimulus. Then it gets inside. So I want you to see if you can innovate only when you are able to realize what you can harness from the actions caused by something that you want or you are dealing with. If you know somebody annoys you, they normally say that your happiness will depend on how you react to people's provocations. The reason they beat up soldiers is to make them so docile, so inert, that if they were gotten somewhere on an enemy line and they torture them, they know how being tortured is, so they don't feel anything. You hit the fella, you even pluck off things, he can't tell you nothing, because he was beaten for free. Now you are beating him for a cause to get information out of him, so he will not give you the information. So how you react to situations depends on the kind of situations you have been administered to. The objectives of the course are that by the end of this course, you students should be able to differentiate between an input transducer and an output transducer. So in one way or another, this could be, especially this one, and none of this the speaker can't be an input transducer. But the idea of a transducer is that it can be an input and an output device. So it means that You can say speaker is a transducer, but this now will be an output transducer. Well, of course, the microphone can never output anything. It is a receiver. I mean, it is the one which is receiving the stimulus. So it will be always on the receiving end. Then you should be able to explain the general principles of transducers and basic building blocks of a communication system. So, and then you should be able to analyze amplitude modulation and frequency modulation signals using the Fourier transforms. I find this becoming outdated in our daily life. Those days we used to do amplitude modulation. Amplitude means that if you have a signal, a sinusoidal signal, can you try to modulate this amplitude here and make sure that you keep it in a given value so that you can transmit it as far away as possible. So amplitude modulation, AM radios are now, and we used to also have shortwave, so you find the radio with shortwave 1, shortwave 2, if it is a 4-band, shortwave 3, shortwave 4, if it is a 4-band radio, but these now are becoming distinct. I don't think you even know what AM is. So I will find this a bit outdated. We shall cover just to make sure that you know the basis. But now we are in with the frequency modulation. Now we modulate the frequency mostly and be able to transmit our signals. And the FM transmission is a point of sight. You've got to be looking at the stuff to make sure that you send the signal. You cannot say, that's why you will be having 91.3 capital FM in Kampala, you go to Mbarara probably it is 92 point something, you go to Mbale it is 90 something, not the 91.3. Because at this point of sight, from Kisimenti to our radios, it is okay. When you cross the Katonga, now you need to have another frequency allocated to make sure those people who are on point of sight are able to get your signal. So this one we shall try to get more understanding, because this is now the trending. Almost all your phones have the 87.5 up to the 108 point something megahertz. So the megahertz. And Haas is one of the guys who utilized the Maxwell's in hustle of confirming that the electric and magnetic fields can move at the speed of light. And then he now started working on how to transmit radio signals across places, and that's why we always talk of kilohertz, megahertz when you are utilizing the frequency. Describe the practical methods for the demodulation of AM and FM signals, the basic circuits of a simple radio receiver, the inner parts of the functioning of a typical multimeter. So that the multimeters we are trying to play around with, not play around with, to carefully use. Now we are supposed to be knowing how you make a multimeter in one set. And then explain the physical effects used in CRO and the following terms used in a CRO, like double beam, CRO, two-channel CRO, chopping and alternating, X and Y amplifiers, time-based triggering, and then the trigger level. So we should be able to enjoy these oscilloscopes and know how they work. You were struggling to use them. I come there, I say, let's change the cable. Then I come, let's try out the other one. Now you're supposed to be knowing how the functions work by the end of this course. And then finally, explain the principles in thermostats, automatic switches, and remote controls. If I don't forget, I'll bring here my drone and fly it around to show you how remote controlling works, but all of you use TVs at home, and you are able to see how the infrared part of from the remote is able to do amazing stuff on the TV. The cars use remote controls and those stuff. So those are the objectives. So now we do the course outline. And for the remaining minutes, I hope I will be able to finish it. Or should I just do like I did last time? And so that we start. Kauma, what do you think if I close the enrollment now and say no more? This balance at least is almost. Okay, I cannot allow one, Shakira, to make sure it's total gender balance. And then the rest I tell them, please try another course. But they were here yesterday. Those who were here yesterday and they have interest in doing this course and they haven't come today, I will chop them off. So let's work on the outline, and so we start with the introduction to transducers. Introduction to transducers. So we have input and output transducers. Input and output transducers. So a speaker is a transducer. This is an output transducer. Microphone is also a transducer, but this is an input transducer. Then we also need to know what a passive and active transducer is. There are transducers which will need power or current to work. And then there are transducers which do not need power to work. I don't know whether you get the idea. Yes, they are part of the electronic circuit, but they can still do what you want even when they are not powered. And then there are those which you must power in order to make sure that they do the work. So then we look at two. We look at the radiation transducers. So we look at the phototube. The phototube, this tube where you have the light entering and then it keeps knocking and getting multiplied, and then by the time it gets out, it's stronger enough so that it can now cause the whatever you want. Then we have this one which I drew here, of these electrodes here, that multiplies your, so a photomultiplier. Then we have a photodiode. Photo is for light, so whenever you see photo, you know there is light. Then we have a phototransistor. Transistor. Then we have a photoconductivity solid. Photoconductivity cell. And then we have a nice sensor that is interesting, the photovoltaic cell. The photovoltaic cell, photovoltaic cell, a solar cell, a solar panel. I carried so smallest. We made a first panel in Uganda from scratch. We had solar cells, built them in Wenare, and made the first panel. And using the lights of my vehicle, we tested it and it worked. So I'm one of the people in Uganda who made a panel in Uganda, the first ones. And the students who had a summer school in Sabizi ended up going into solar stuff. I'm sure they should be now experts in some of the things. So a solar panel would be an example of what I'm telling you of those which do not need power. You don't need to power a solar panel in order to act as a sensor or a transducer. You just put it on the roof, sunlight comes, it sends the current into the system, whatever you are doing, whether you are using it to charge or directly harness the power. Because there is fluctuation, the idea of regulators, because there is fluctuation of the light that is shining on the panel, either because of the cloud cover or any other issue, then you can't have consistent amount of photons landing on the solar cell. So you need to have a regulator to make sure that you have a particular an amount of voltage that is at a given range because of the regulator, so that you have the charging taking place. And also you have to integrate a charge controller on your panel before your inside system. You have to make sure you have a charge controller, so that an amount of charge is the one allowed to go to your system. Otherwise, you cannot have the charge going up, charge going down. Charge going up, charge going down. You must regulate it so that it is consistent. Remember a trick I told you about of if you overcharge the battery, that you need to put a diode in your system, in your radio, to make sure that the extra charge does not spoil your. It should be lost in doing the dissociation of the charges, creating the gap. What is it called? I've forgotten. This gap between P and N, we call it what? When I bring a P and an N, and then you have charges shifting, and then you create, that one is called what? Which gap is that? The depletion region. So by the time you create the depletion region, the charge which was extra on the battery has already been utilized. Then you have now. But if you just put and nothing is there, that extra charge will go in the circuit, burn up your circuit, and then you find that your radio is gone, and you have to work on it to do whatever you want it to do. And then we have a light emitting diode. Light emitting diode. Light emitting diode or LED. And then liquid crystal displays. Liquid crystal displays. I really used to enjoy this when I was young. This display here on this robot here is a liquid display. When you touch, you feel even things are like if you have a digital watch and you try to press, you see the dark liquid trying to move away from your finger. So that is the liquid we are talking about, liquid crystal display. Then you also have LEDs, which are the light emitting direct displays. So if you are watching these stages they erect on concerts, they are made of LEDs, light emitting diodes. They are arranged in a way, and then eventually give you a big screen. When you are near it, it looks fake, but when you go away, the illusion, by illusion you see a nice picture, movies. You can watch a movie, but it's not crystal clear. Then we look at the thermoelectric Thermocouple is simply having two metals at different temperature, and then a current is formed, a voltage is created across, harnessed, and that amount of voltage gives you the value. And you can translate that value into the temperature value that you are trying to measure. Since the more the temperature, the more that voltage will be. So instead of reading volts, you are reading kelvins or degrees Celsius, whichever scale you got. But actually, what is happening because of the difference in the temperature of these two joints, giving you the voltage, which eventually is calibrated into or is taken out and given out as the temperature. Then you have a thermopile. Thermopiles. And then we got the bioelectric detectors. Bioelectric detectors. We have a pyrometer at the other side of the whatever pyrometer. It looks at the sun and then it gives you the intensity of the sunlight that you are getting if you wanted to use it in harnessing solar energy. 4. We have mechanical detectors, the touch, the press, whatever it is. So we have mechanical detectors. The weighing bridge uses this analogy. The truck comes, presses on it, and then you get the value. So these are strain gauge, then piezoelectric. They are materials. These materials, when you exert pressure on them, their electric properties change. So you can use that as an advantage of similar to the soldiers. Those days when we were young, I think when this government had just come in, there was a roadblock. So this soldier would cane people, and then they would also cane him. Like when we would report him that he canes people, and they have caned him, he comes when he even can't walk. Then when he heals, he also canes. So it's like he was transferring his pain to the citizens. And then when his bosses hear that he's misbehaving, they also cane him. So they are materials which, when they feel the mechanical stress, then they change in the properties. So you can interpret that change in the properties in what you want to measure and relate it to what strain. You remember the vicious cycle in psychology, those of you know education? You kick a chicken bites a snake bites the mom canes. It's a vicious cycle. You find that the violence cycle goes unknowingly. If they annoy me at home, then I'm supposed to teach at 8. You see me when I'm moody. And then you also go when you are annoyed. Someone asks you, how was the lecture? Don't talk to me.
Why did you attend?
Why did you attend? Where were you? So, something like that. So these piezoelectric materials, the effect of this can be harnessed in a sensor. And then we go to the advanced one, which is the use of the phone. 5, capacitive transducers. Then we have inductive transducers. Then examples of, I don't want to There wouldn't be any issues. So this is the, I did come with a box because it was heavy, but these all parts are small parts which they are removable. They are just pieces. So they are in a box. I arranged them in a small vera, so you have to put them together. There are instructions online. And then after putting them together, there's nothing like me marking later. The marking is almost there and then. If it works, if it moves, then it will show that you work. So this is called a line follower. It follows a line. So it has light here. It has a light source and also a sensor of that light source. So when this light goes on the material, then it detects the difference in the intensity and then follows that line. So these are just tires. So it has a brain. This is the brick, which is the brain. So I'm going to look for the under files, look for line follower, then choose it. And then when I switch on, the light will go on, and then there is a sensor. One is giving out light, the other one below. Here I have no line, but it has seen a line differentiating here. Otherwise, if I put it in the mirror here, it doesn't see anything. So I'm going to look for I'm going to make the line myself and see whether it can detect it. So there's nothing here. So I'm going to see whether it can sense and follow. So I'm going to make a line and see whether it can really differentiate between these. I wish I could get black, but so it was just moving around fakely last time I did this. So now we're going to see whether it really makes the choice. See? So it saw something but couldn't follow it. It was trying to follow. So there is a map. I found that I didn't come with that paper. There is a map for the so it feels it. It had almost now seen it. So so anything you put, it feels it. Now it has followed a bit of it. Let me see here. Now it has followed the line to this other side. So it has a programming, it can be programmed. It has a programming platform where you can change a few parameters. But as long as you can build it during the practicals, once you get pieces, arrange them as a group, build it, and it moves. Me, I will be very happy. Just touching, that you will be able to use it. So just touch. I want you to know that. So when you hear robotics, this is why I'm always annoyed when I hear people saying, we are now into industrial revolution, the fourth industrial revolution. We are in AI. Me, who has been playing around with robots, I just laugh. I say, okay, so you think we are now in what? So we shall do that component, and then tomorrow in the afternoon we should be able to finish the outline. Hopefully, if anyone doesn't come tomorrow, really, it means they are not interested. And then we do the basics, agree on a few things, and we should be able to enjoy this course. Press the down one, the black one. We don't follow rules. We don't follow rules, we just want to try out. So, because I want to be done, so that I attend the seminar. I'm not attended for some good time, so this semester I want to do it before. So I intend to make sure that by the time we finish this course, you really have something to say I studied. Now, and because the reason I insisted that I do this course with you is because of how we spend more time on electronics. So I wanted to show you the electronics we struggled to work on. Where does it help us when we eventually have to use it? So I can't be mad at him. Everyone would want to try out. It's just built, those pieces are just built together. So you have servo motors, those ones where the tires are. Then you have the brick, which is that big thing. And then you have the sensors. And then you have the communication. The communication wires, which are those cables. So it will also help us understand the communication system, how the system works. Any question? I could have finished if you didn't come late, if I didn't start late, but I'm sure this symbol will always just help us for tests and trying to, you know, do some kind of tutorial. But the good one will be the afternoon, the evening one of tomorrow. Because would you have a lecture at 7? So I can call you and go up to 8. Sometimes. Okay, it means that I would not be in a hurry when it is the lecture of tomorrow that I'm in a hurry. So we see each other tomorrow.